The object of a spheroid would be the navigation between each part of it. So if a spheroid is split into three, and each three has 4 layers in it, which means it's a curved apparatus, these curvatures are singular in noun, which means at the apex point of the sphere where they cut apart, they denominate valvatures for each part of the sphere's bending. So if a sphere bends, not only is art designed from its interior, art gets replaced with economics. So the interior of the sphere would be the very center of it, where navigation occurs. And navigation of the sphere would be part of a path between the hemisphere and the longitudinal sphere. So if longitude of the sphere has latitudinal marks on it, then it has a severity of how each part of it begins to dimension, which means the dimension of the rectangles between it would actually be part of a hemisphere in itself. So since these are spheroids on spheroids, not only does the dimensions of the second sphere you get from it begin to show arrangements of how the sphere begins. Once you navigate the second sphere and it does not reach its apex point, which means it's a rectangle rather than a ordinary width of a rectangle, this would be a semi-sized conductor of a watering of Welshes. So these Welsh trademarks are actually how litmus testing is done on the fabrics. So if fabrics has a decaying point, not only do these watermarks of 0 on apex occur, they have little rings of approximations of 0. So how these zeros occur are the bending of the latitude marks. So if these latitude marks aren't straightened out, they have oval trademarks that keep them alive. And if you measure these ovals, not only do you get the width of the sphere, you get the equation for equalities between them if you add all 4 of them up from the rectangle. And this is what a Dianogues is. A Dianogues is that you can add up all 4 ovals and get this correct answer for the arctan of the sphere, which is the equation for height.